will get the same scenario, but what other changes are there? See, now they are saying the push button of the wall mount out is released and it returns to the original position. So small parts to be you can attach to the piston end, and then you can move it from one to another. So that particular load, when you have delivered over there, so then due to that loading, once it is delivered, then due to the spring force, gradually it starts moving back. And when it starts moving back, it has to escape. So that escape again, you can see in the next diagram, the button marked in is pushed to operate the wall. So now you can push this in button, air escapes and the piston rod moves to the in-stroke position. The push button must be held operated until the piston rod is fully in. So you need to keep pressing the push button. Atmospheric air will be drawn into the front of the cylinder through the vent port. So that is what happens over there. So now this has completed one complete cycle. That is first position when we started off, it was the same position right now you are observing. The only difference is that in wall is having exhaust port connected. While initially when we started off, both the walls were in shut off condition. So that is what the air was trapped over there, and the default position was assumed by the cylinder. But in this particular case, unless the air escapes, piston cannot come to the extreme left position. So this has now completed. We started from the extreme left, and then again we have reached to the extreme left. So this has completed one complete cycle of operation. So in stroke and out stroke, so it completes one cycle, but then we need these particular circuits for different applications. So we can modify this particular circuit. Now what we can do with this circuit, probably if you have seen the last one or two videos, you may be able to point out what can be done. This is what it is being left to you. What you want to do the modifications to this particular circuit to improve its feasibility, to improve its application, and to improve its performance. Lot of other things are possible. See, whenever there are pneumatic system, there are some basic issues with that system. What basic issues are there? You might be aware. So you should be able to address those issues. These are actually pertaining to the design aspects. Anyway, but if you have seen those videos, last at least two videos, what modification we can suggest? Because those modifications are there now. Again, next slide, we can have those modifications. But if you can suggest any of the modifications, firstly, I would like to know. So, is it understood? This operation is understood. Shlok, is it understood? Nivrutti,
Yes, sir.
okay. Monil is there.
Yes, sir.
Monil, complete darkness. What happened, Monil? Are you there or not? So this is what the scenario is there. Okay, I can just suggest one thing. See, in the current position, you are applying full pressure with the push button, then it is giving you outstroke, and then again from the other end, if you are pushing, then it is getting the in stroke. But in between this, so we can add different elements or walls which we have studied earlier. You can have check wall, you can have control wall, you can have pressure relief wall. These all walls will only further improve the functioning of the system. and basically you can regulate the pressure correctly. See, I already told you people these systems work in some range, that is 3 bar to 8 bar. Sometimes if you are exceeding unknowingly, if you are exceeding that pressure, then the entire circuit will explode. So that is what I told you, because the similar thing is there. Now suppose in our lab, I don't know whether you have visited a heat transfer lab, um, because last 2 years now your people are not there. But there is one compressor in heat transfer lab. Its capacities are in, I think, 12 to 15 bar. So from there we have taken this pneumatic connection in the measurement lab at the first floor. So sometimes it may exceed, that pressure may exceed well above 8 bar. So you need to keep checking it all the time, and you need to regulate that pressure. If sometimes, if unknowingly it moves ahead of 8 bar, then anything can happen over there. So for such things, you need valves which can regulate the pressure. You need valves like pressure relief valves. If it exceeds in particular wall, it can be released that pressure. So all such valves, if you are adding to this present circuit, it will only improve its functioning. Now again, the next position, they are saying if the button marked in is released, the piston rod will remain in stock position. Any leaks in the installation can cause piston rod to creep. And then again, both the walls come to the original position, that is, both the walls are in shut off position. So this is how small details uh, are being worked out over there, and each detail I tried to put it into separate slides so that you can clearly make out the difference, what difference of positions are there, switching position, port position, how it is being changing all the time. And this is what I just told you people, that you can add some of the walls to the existing wall. Now to control the speed of the piston rod, flow restrictors are placed in pipe close to the walls. And adjustment of restrictors will slow down the flow rate, thereby giving independent outstroke and in-stroke speed control. This is more important, independent speed control. In both the strokes, there are requirements sometimes that you need to have accelerate in the working stroke. You need to accelerate sometimes in the return stroke. So it depends, or you need to decelerate. So all those regulations are possible. Lot of applications are there. Suppose, for example, your hammering operation is there. Hammering means simply giving blow to the particular part, it will get conveyed. So such operations with some specific speed, it has to move. Some load is attached at the end of the piston, it has to move slowly. Then you can regulate the speed at such applications. So whole lot of applications where you need to regulate the speed. So for all such applications, you can have these wall, that is regulator wall, restrictor they are calling it. So these walls are placed at the, you can say, outlet of the walls, two walls which are indicated. So these restrictors, or these are something like orifice kind of structure is there. So orifice you people have seen earlier. So something like that, if you are attaching to the outlet of the walls. So if at all there is a question regarding the independent speed control for the in-stock and out-stock, this is how you can draw these circuits. Now this is explained further, that is, by repeated operation of either button during the movement, the piston rod can be moved in small step for approximate positioning. This will only be successful under slow speeds. So there is specific requirement that for that we have deployed these restrictors. This is another application now, or another addition of the other device, that is, with any compressed air system that intentionally traps air, the potential hazard of this must be recognized. Unintended release or application of pressure can give rise to unexpected movement of the piston rod. A pressure indicator or gauge must be fitted to warn the presence of pressure. So this is what happens sometimes. If you are not having close watch on it, then sometimes, as I told you, it can go beyond 8 bar pressure, and then it will suddenly explode the entire circuit. And that kind of accident has occurred once, say, I think around 10 to 12 years back. So it directly exploded the cylinder, and that piston struck the ceiling. So it was that much amount of pressure was exceeded over there. After that, we are taking regular care of it, so it should not be repeated now. But if the intention is to observe the pressure, so in the pressure line we can have another gauge attached over there. Similar gauge is also there. The setup that we are performing yesterday, you might have seen in the simulation videos. There is one circuit called FLR circuit. That is filter lubricator rectifier circuit. So this filter lubricator, so they are regulating as well as filtering and lubricating. So it is taking the care of the entire circuit. So whenever actually we get the compressed air from the compressor, it is first given as input to this FLR circuit. So it is processed in the FLR circuit, that is filtered and lubricated, and then it is provided further to the walls and cylinder, whatever is there. So a lot of other things can be avoided with the help of that FLR circuit. So this is the intention to add pressure gauge, so that continuous monitoring can be there. 2 by 2 wall. Now similar things are possible with 3 by 2 wall, but you need to make some change in the connections. Suppose now you want to have actuation with the help of 3 by 2 wall. So how will you make the connections? What will be the switching positions? What will be the port position connections or the port positions? That you need to think. Now, immediately after this diagram is there, but I'm not directly shifting on over there. You can just I will wait for another 1 or 2 minutes. You can just try on your own. So 3 by 2 means what? Three ports and two positions. So you can draw that wall. Earlier also we have seen in the symbols and all those, which I have already uploaded into the classroom. So this 3 by 2 wall, how will you connect and what will be the position of the port? That you can just try, so that you will understand later on what kind of mistakes, and it will clear your concepts. Confusions will be cleared very fastly. If you think this way it can be connected, and immediately in the diagram, if you think that, okay, it is being connected like this, then you it will clear a lot of your doubts. So I want you to just try for a minute or two, connecting 3 by 2 to the cylinder. Just try it. We will discuss it further. I think 65 students have given the response to that lab sheet. So I will make responses of now. You just try connecting the cylinder with 3 by 2 wall. Now, whatever kind of wall you want to choose, you can try attaching over there. Important thing is that uh, are you able to make it out about the switching position? Means when you are connecting in one of the position, what will be the port connections in the immediately next switching position? That also you should be able to indicate correctly. And this is more importantly a 3 by 2 wall. Earlier, what we have seen was 2 by 2 wall. So there is one basic difference which you need to note down and which you should be able to incorporate in your connection. I guess Mounil is not there, na? Mounil?
Yes, sir. Present.
अरे तो कहाँ डार्कनेस में चला गया इतना? अभी पहले भी हमने पुकारा तुम्हें.
Sorry, sir.
I called you earlier, so there was no response.
Oh. नहीं सर, मतलब मैं लेक्चर में वो सुन रहा था पूरा टाइम में.
Okay, okay. Okay, I will complete. So you can just try. I will complete attendance by that time. Ayush is there. Ayush, Abhishek.
Sir, Abhishek Thakkar present.
Yeah, Abhishek Pillai.
Yes, sir. Yes, sir.
Ayush is there or not? Ayush, Adesh, Aditi, Aditya, Singh, Amar,
Present, sir.
Yes, sir.
Present, sir.
Aniket, Anjali,
Present, sir.
Anushka,
Present, sir.
Present, sir.
Arnav, Arya, Ashutosh,
Yes,
Athurva,
sir.
Atushi,
Present, sir.
Yes, sir.
sir.
Bhushan, Chaitanya, Gufran,
Present, sir.
Gurpreet,
Yes, sir.
Yes, sir.
Gurprasad, Harsh, Harshada,
Yes, sir.
Yes, sir.
Harshal, Hemant, Jay,
Yes, sir.
Lode, Jaivir Singh, Karthik,
Present, sir.
Yes, sir.
Yes, sir.
Jayant is there. Jayant Devmore,
Yes, sir.
Kaustubh,
Yes, sir.
Kaveri, Manas,
Yes, sir.
Maunil, Mohammad Saif, Mrityunjay, Mugda,
Yes, sir.
Yes, sir.
Munish, Neha, Korde, Neha Korean.
Yes, sir.
Yes,
Yes,
sir.
Neha Korean, you Neha joined from two devices. Nikhil,
Yes, sir. Mic is not working.
okay.
Yes, sir.
Nivruti, Prafulla,
Yes, sir.
Prajakta, Pratik, Rahul, Pancha, Rahul Yadav,
Present, sir.
Rajiv Kak,
Present, sir.
Yes, sir.
Rakesh, Ravi Desai, Ravi Parmar,
Yes, sir.
Ritvik, Sagar,
Yes, sir.
Sakshi, Saloni,
Present, sir.
Yes, sir.
Yes, sir. Present, sir.
Sarang, Sarvesh, Sharwari, Shivpriya, Shlok,
Present, sir.
Shreyas.
Present, sir. Hello.
Shivpriya is there? Ab- Shivpriya is there? Shrikant, Shruti,
Yes, sir.
Yes, sir.
Shubham,
Hello,
Shubhangi,
sir.
Yes.
Sir, I am Rahil Parekh. I was on mute actually. I was not able to switch on my microphone.
Okay, okay.
Yeah, yes, sir.
Srushti. Okay, okay. Srushti, Suraj, Tanmay,
Yes, sir. Present.
Yes, sir.
Tejas,
Yes, sir.
Varun, Vedant, Vishwajit, Yash,
Yes, sir.
Yes,
Gaikwad,
sir.
Yash, Gankar, you are.
Yes, sir.
Yes, sir.
Okay, so I hope you might have tried this particular thing. That is, if you are making the connection for 3 by 2 wall, what kind of connections are possible? Now, once you see this diagram, you will be able to make it out what kind of connections are there and what you have done. More important thing is when you are drawing switching position, what connections you are proposing in the next switching position. If you can do it correctly, then a lot of things you will be able to understand later on. So this is what the 3 by 2 connections. So 3 by 2 wall is connected. So this is the default position. Again, it is assumed that is uh, cylinder in retracted position, that piston in stroke. If that is the condition, what wall connections are indicated over here. So a 3 by 2 wall, a 3-port wall provides the inlet and exhaust path and is the normal choice for the control of a single acting cylinder. This wall is more preferred than that of your 2 by 2 wall because we have just seen two 2 by 2 walls we actually require. So that is the limitation for the earlier circuits which we have seen. And obviously, if more number of walls are there, then your entire managing those functions becomes critical. In the normal position produced by the spring, the wall is closed. Okay, so this is the normally closed position. Outstroke, exhaust is indicated over here. In the operated position produced by the push button, wall is open. So this particular statement, the meaning of this statement, you can see in the next switching position or the adjacent square block right now. You can observe. So there is an arrow indicated over there which indicates the air supply is on and exhaust or another supply exhaust is shut off condition. So it is obvious if air supply is on, piston will move on to the outstroke position. So the push button must be held down for as long as the cylinder is outstroke. So if you want cylinder to remain in the outstroke position, keep pressing it. If you release the pressure, as we have seen earlier, with the spring force, it will come back to the extreme left position. In stroke position will occur over there. Okay, so this was the default position that is we have assumed. Now the second condition, that is we are assuming now button is pressed. So if button is pressed, what will happen over there? So this is nothing but what we have just seen in the earlier diagram, which was shown in the square here. So here in this square, you can see air connections were indicated, and the same connections are in the connected position indicated over here. After pressing this push button, now this wall is getting connected and air supply is given. Once air supply is given, piston will come outside. So, but exhaust is being kept shut off position. Otherwise, if exhaust is there again, you will not be able to complete this. The more important thing is that you should keep it in press position. This push button should be in press position. Otherwise, if you release the pressure due to spring force, it will come back. So a 3 by 2 wall, 3-port wall provides an inlet or exhaust path, and it is preferred for this single acting cylinder. And this is the requirement. You need to keep it in press position. So this is what happens in 3 by 2 push button wall. Okay. So again, the same question arises. That is, this circuit is there Now this is how you can say basic circuit. We need to improve its applicability, its flexibility further. What other things we can add, that we can think now, wow, what is the purpose of adding all those things is more important. This is next position indicated over here. So once you release the pressure applied to the push button, this is the scenario what will happen, that is exhaust get connected. Exhaust gets connected means what, you will try to recall the constructional feature, what construction, how the ports can be kept open and how it releases the air pressure. So that you will have to imagine. So once you are releasing the pressure, due to the piston, it blocks the air supply and it releases the exhaust port. So that is how the air can escape through the port. So this is indicated in this diagram. And now further addition is there in this diagram. So to generally slow the cylinder speed, an adjustable bidirectional flow regulator or fixed restrictor can be used. Bi-directional means what? This kind of wall is there in our lab. There is a, you can say, what kind of structure is there. You're moving, you're rotating it, so you can rotate in both the directions accordingly. In both the directions, air supply can be regulated. So the flow regulator setting will be a compromise, as the ideal outstroke speed may not produce the desired result for the outstroke speed. So this is purely the requirement of your application. That is why we are doing it like this. That is, you need to slow down the speed. If you don't need to slow down it, then you can directly have outstroke position. But as I told you, there are some design aspects involved into the pneumatic system. That is, if you are pressing it with the full speed, there is a shock occurs. Since the air is trapped in between, so with that shock, there is always a noise that is generated. And with that shock, again, the stroke completion is not ideal. So these aspects are also there from design point of view. So to avoid this sudden shock or noise which is occurring due to the sudden speed which is being applied to the piston, so the requirement of this restrictor or regulator wall is very important here. So from design point of view also it is quite helpful. Just a minute, I am putting something again. So this is now I'm putting the link for the lecture, today's lecture. So this 3x2 wall is there. Then again, you have seen this earlier position. There is another addition that we can have for this wall. That is, again, check wall is also added over there. So now obvious thing is that if you want to have unidirectional flow, we have seen in the symbols, it will allow to flow in only one direction. And if you have seen those videos yesterday, they have clearly shown how the flow takes place in these check walls also. So to control the outstroke speed of the single acting cylinder without controlling the in-stroke speed, a unidirectional flow regulator can be added, and the flow into the cylinder closes the non-return valve and can only pass through adjustable restrictor. By adjusting the restrictor, the outstroke speed of the cylinder can be set. So this is what specific requirement. See, whenever we are using these circuits, some specific applications are there, and these specific applications demands all these things, that is non-return wall or restrictor. So obviously, if you want to control the speed in the outstroke position, this is what check wall you can again add to that, and then both the things can be taken care of, that is unidirectional flow as well as regulation of the flow. This is another interesting addition to the previous circuit. So now what they are saying, this is for the independent speed control. We have seen the independent speed control in 2 by 2 wall. Now this is the independent speed control in 3 by 2 wall. So for independent speed control in each direction, two flow regulators are required, installed in opposite direction to each other. Upper regulator controls the outstroke, lower regulator controls the in-stroke position. So we can imagine here, as the arrow is indicating in that wall with the flow. So for that inlet there is another return wall. For outstroke there is another. So these two independent speed controls are possible over here. Have you understood this particular diagram? Yes, understood. Yes, Gang Shettiwar, Vedant, are you there? Varun?
Yes, sir.
Okay. Vedant is
Yes,
there or
sir.
not? Vedant,
Yes, sir.
are you there?
Yes, sir. I thought my mic was muted and so I was unable to speak.
Understood? Understood.
Yeah, yes, sir.
Okay. So this is addition to the previous circuit. Now again the next we will. This is just the completion of the stroke that they are explaining over here. So a three-port valve provides the exhaust and inlet path and is the normal choice for the single acting coolant. So this is what we can have. Similar repetition is there for the explanation. Both these speed controls can be possible. But this was about the 3 by 2 wall. Now another popularly used wall is 5 by 2 wall. This wall is very popular. Can you just try, or I will leave it to you, because again time is also now we are nearing completion, so it's okay. But I will not go to the next slide. I just want you people to draw circuit in which 5 by 2 wall will actuate the cylinder. I'm not giving you any specific condition, any specific selection. Just you try to draw a 5 by 2 wall and connect it to the cylinder. After that, different port connections you can show in two different positions. 5 by 2 means what? There are five ports and two positions possible. Two position means on and off, that's all. So if this kind of wall is connected, how will you show the connections? Very important thing. If you can draw without referring any other thing, you can understand all the complicated circuits later on. Whatever the other complicated circuits we will be studying, it can be easily understood by you. Lot of doubts will also be cleared in the meantime. Okay, so I'm leaving it to you. We can stop here for today. 5 by 2 wall connecting the cylinder, just try to draw. You can, if you feel, you can also forward it to me. So I will just have a look at it, and I will actually understand to what extent you people are able to do it. Okay. Okay, then we'll stop here for today. You can just register your attendance again for this lecture and you can leave. Thank you. Any doubts are there, you can just put up over there in the feedback. Okay, bye.
Thank you, sir.
Okay, thank you.